Hi everyone, I am Rajkamal and welcome back to the brand new series of AI product engineering. And in continuation to that, today I'm going to talk about Docker, which is very important, very essential skill for you as a aspiring AI product engineer. I mean, it doesn't matter if you're a fresher or you're working professional, you cannot skip Docker nowadays. This is the current trend and this is very essential open source platform which you feel that very important when you are developing a production grade system end to end. Okay, so in today's topic, since this is the introductory topic, episode 1, I will talk about Docker theoretical aspect as well as some practical aspects so that you can confidently enter into the journey of Docker and you can build end-to-end product with the help of Docker containers confidently. That's the whole idea about making this video. Okay, so without further delay, let's get started. Okay, all right. So currently I'm on the blackboard. So let's start the discussion. So so my approach will be not jumping directly to the Docker first. Rather, I will explain you how we are doing the development and what are challenges, real-time challenges, issues we are facing in real time so that you can able to connect the dot. I mean, what all challenges were there and why Docker got introduced, right? Because to address those real-time issues, Docker came into the picture. And that's how you are able to relate each and every point. So that backtracking is very much important. So if I talk about, I mean, the story about a few years back how the development used to happen in real time. So suppose I am Rajkamal, I'm working as a uh, team member on certain client project. Let's say this is a RAG application. Okay, so let me use my pen tab as well for that for better explanation. So I'm talking about Docker today. Docker. Okay, and it is the pre-era. Okay, what was happening prior to Docker implementation, right? Or Docker way of implementing the real-time application. So, as I was explaining, so there was a developer. His name was Raj. Okay, so he was using Windows machine, let's say, for the development, and he was developing something. Okay, or some project, and it was kind of RAG application. Since we are a AI product engineers, so definitely we will be using these kind of application, right? Agentic based, RAG based, Genia applications. Okay, all right. So so first of all, he is using Windows, okay, as a platform, and then in order to develop that RAG application, he was there is a concept of requirement.txt basically. So just wanted to give you some background about it. In order to develop any application, we could require a list of dependencies libraries with certain versions, right? So those things also we need to keep a track inside the project in form of requirement.txt, and then we generally install those dependencies and start building our application. So there will be one file as well, right? Requirement.txt. So just trying to breaking it down. So OS wise we are using, Raj is using Windows, and then there is a project dependency requirement.txt file which contains all the libraries details which are required in order to develop a RAG application. And this requirement.txt, it will contains all the libraries which is required to develop the project. So it could have some, let's say, suppose we are building a RAG application, we are using LangChain library. And suppose we are using zero point 0.1 version. Okay, this is the initial version. And then we are using Python as a programming language as well. So it is like when the development started, that time Raj was using 1.30 version. That could be the latest version at that point of time. Okay. And then he could be using some vector DBs as well, which could be files, could be Chroma or Pinecone, let's say. All right. And it will also, be having some versions. Suppose it is a V1 version, Pinecone also having V1 version. Okay. Okay. All right. So Raj has worked very hard and he completed this application with all these dependencies and on this machine which is Windows based. Okay, and as a result, this application is this project is completed. Now he is able to build it successfully, run it successfully, and then ship it successfully. Shipping part. Shipping part as well. Shipping is also done successfully. Okay, all right. And what happened after 2 3 months or after 6 months? So till here, everything was working smoothly without no issue, right? Then after 2 months or 6 months, a new developer whose name is Kamal joined the team, and he also started contributing to that project. Okay, so what happened at that time? He was pretty much senior person, senior. Okay, so company has given company has given some different machine. That laptop was, I would say, Linux based or Mac OS based. Let's suppose I'm considering Linux based. Okay, that is the machine that person was using. That senior person was Kamal. Okay, and he also is, in order to start contributing into the project, he need to set up it locally, right? So the version and all those things which he has set up for the project execution. So if I'll talk about his requirement, txt file, right? So it also contain Python, but after 6 months, what happened? Some new version of Python got released. It was 3.14 version, let's say. And now LangChain as well, because every company, right, they are they are just upgrading their self and keep on adding new features as a part of new releases. So as so the LangChain as well. So they have, upgraded from zero point 0.1 version to zero point 0.2 version. Okay, after 6 months. So Kamal has set up LangChain or 0.2 version for his development. Then the vector DBs which he has used, probably suppose Pinecone, he used some different version he used, or suppose for the LLM integration, so he would have used LangChain OpenAI library, some different version, right? And suppose that time Raj was using LangChain OpenAI V1 version. All right. So that was the setup of Raj, and this is the setup of Kamal. Now when let me change the color. Now when Kamal started running this application, rag application, right, he just take the pull from the current repo of the project, and with this set of requirement.txt file, where he is using different version of libraries on the different machine. What he finds, his project started failing. The build was failed. Okay, and the reason was project dependencies conflict, some version conflict. Might be the project which Raj has developed with some different set of libraries version, it was compatible at that point of time with that set of versions. But when Kamal started running the same project with different set of different set of versions of even same libraries, it started breaking, because there is the change in, there is the conflict in the version, and that is a real time problem. You would have seen that the same application which was running earlier with different set of libraries versions, that eventually got failed when you tried running with the help of newer version of same libraries. So there is a version conflict, and that is the real problem, guys. Okay, so to address that issue, Docker has a plan that I will be discussing. But before that, I'm just trying to convey, just try to understand what all challenges were there in the pre-era of Docker. It was dependency on the machine OS, underneath OS that we are using, because even depending upon Windows machine you are using, Linux machine you are using, the way you build the your project application, your project code, right, and even the command varies. It varies OS to OS. And even if uh, there are changes in the versions of same set of libraries, even though it will start throwing an error, and this problem is very real. And I will give you a very common line which every developer would have said in their past, and if they are not using Docker, they were saying the same thing in nowadays as well, that this application was running successfully, was running properly in my machine, but I don't know why it is not running in your machine, right? This is a very common problem. And the solution is Docker, because there are a lot, so many things which are variable. Okay, let me explain you what all things are variable. So guys, this is pretty much important, you to understand what all things are variable. And if you're not controlling, not fixing, or not streamlining those things, then we cannot overcome those production grade challenges, issues that we are facing earlier, right? So let me jot it down for your reference as well. Okay, let me use which color? Let me use this green color now. Okay, make it colorful. Okay, so what all variables we are struggling with? So first and foremost important point is the machine, right? The OS we are using. Suppose it could be Windows, it could be Linux based, and even in Linux there could be different flavor, Debian, Alpine, sorry, Pine, it could be SUS, Fedora, so many things, right? And the different machine could be Mac OS machine, right? And here also there are different varieties. So what I'm trying to understand, the first variability is in its platform itself. We are using different platform, right? And how can then we can expect that this, if something is working on Windows, it should be successfully work on Mac OS. This statement is incorrect, right? Without testing, we cannot guarantee anything. So for that, there is some plan that I will explain as a solution what Docker is offering. Then another variability is this requirement.txt. Even though people are using requirements.txt at project level to handle all the dependencies and do the development, but still they are not freezing the version. So suppose Raj was using 3.10 version, then Kamal was using Python 3.14 version. We cannot guarantee that the LangChain version 0.1 version that was working as expected with Python 3.10 version, it will also work with 3.1 version, right? It could break. So every software comes with their support at high level. At till that version, we will be supporting this functionality, that functionality, and after that, these things will be deprecated, and we won't be further supporting those. So in that context, I'm telling you, this combination matter. What all application you have developed with what all with what all combination of libraries and versions, right? If you will play I mean if you are not freezing that, and if you are changing these versions in upcoming projects, right, so things will started breaking down. Okay, so these are the two main challenges that I feel it, uh, that these are the real pain areas, and if we are able to successfully address this variability with the help of Docker, we can successfully address the issues that we are facing before the uses of Docker, right? In earlier days, in earlier developments. All right. I hope now at high level you understand why Docker is important for you as a developer, for you as a implementing a production grade, I mean high end system. I mean there are so many things I will letting you know. Okay, just give you a glimpse about that so that you can think of that big picture. So guys, what happens in real time, if you're talking about a real time application, okay, so there will be a client which will be interacting to your nginx web server, and it will talk to it will talk to different components of your application. So you could have front end component and its related services, then you could have backend component with related services, and nowadays every other application they are implementing uh, AI services as well, right? So try to understand one thing. In order to cater big this much big application, right, you would require some underneath uh, some advanced technologies where or advanced framework, so that we are not struggling with these libraries, version dependency, version conflict related things, or some OS related stuff. So to get rid of those things, nowadays in industry, people started using Docker containers underneath. Okay, so there will be separate Docker container running for front end, separate for back end, separate for AI services, and then separate for nginx, and they will be talking to each other. Okay, because these services will be exposed to the particular ports, and through that port, those communication will be made with the internal networking supports provided by Docker. Okay, so things are very advanced, and what I'm telling you, this is a very small architecture. Even on top of that, there will be some DB services. So a separate DB container will be running underneath. Okay, and suppose it's running on some 54, 53 port number, and then it's talking to backend, and there could be some caching system as well. Caching, right? Separate container will be running for that as well, and it will be exposed. Suppose Redis is the example for this caching service, and it will be exposed or running on certain port, and from that port, this backend will be talking to each other. Then even this backend will be talking to AI as well, right? So to cater this, I mean, this much big application, which has enormous number of component services underneath, to make it very smooth, networking wise, communication wise, security wise. So there is a need of containers. We cannot just waste our time fixing this libraries dependency related issues or OS related issues. So we have to streamline, and that's where Docker came into the picture. So let me talk about that thing as well. Now it's time to talk about Docker in detail. Okay, all right. Let me change the color of this my pen. Just click it. Let's use this brown maroon one. Okay, so now I'm talking about Docker, guys. Okay, so this is the post era. Here in Docker, you understand what was the issues, and how Docker how Docker came to address those issues, right? Now let me break it down step by step, so that you can just understand in much better manner. So for that, I need to just deep dive and explain about the other components of the Docker as well, so that you can able to understand. So guys, to fix the baseline, the OS, that is pretty much important. That should be the first step in order to streamline or make things common across the environments, right? Be it dev, QA, or be it on premises or local or cloud, right? So for that, OS is something which is pretty much important for the development, right? So Docker try to fix that image part first, or OS part first. So that is the image concept or image terminology under the Docker itself. Okay, so what Docker says, I will fix the OS issue now. Now going forward, whatever the development we are doing, our team is doing, our cross team is doing, they will be using same OS. So image is what? Image is nothing but a light-weighted OS. Okay, all right. Some light-weighted OS. Okay, the prime example of that is Linux, Debian, that I will show you practically as well. L fine. And their size depends. I mean, the Debian OS or Alpine OS you are using, this is with respect to which service. If it is a Python specific, or it's a caching specific, it could be 25 to 50 MB of size, right? So generally you can understand it will be lightweighted. It could be 25 MB, it could be 1.5 1.1 GB as well. It depends. It depends what type of service is already coming as a package of that image. If it is a caching, so definitely it's a very small in size. It could be of 2.5 sorry, 2 point, not 2.5, it's 25. It could be 25 MB, or maybe less as well. So the idea is it will be the lightweighted OS, not as a high in configuration as a typical Windows or typical Linux or typical Mac OS is. Okay, and they will fix this OS, that going forward everyone in the development team, they are going to use Linux Debian only, or Linux Alpine only. Okay, then there is a concept of container. In order to understand container, so you can think of this image are static, or they are in rest. When they are running, it will become container. So running OS, I would say, they are nothing but containers. Okay, then there is a concept of volume. So when you will be working on some application, let's suppose uh, you're using MySQL DB or Postgres DB, and you want to just store some user customer related data, or some project related data on that OS, right, on that container. So volumes comes to handy in that scenarios. It will provide you persistence storage to store those project related data or whatever you have planned permanently, right? It will not vanish when the container is restarted or container crashed. So this is not a temporary memory. This is not running or storing. We are not storing something inside the RAM. We are storing everything inside the disk. That thing also I will practically explaining you, because everything set up already in my system. So you are going to enjoy it really. Apart from volume, there is another thing, which is I would say the networking part. So as I was explaining, when some image you have pulled, right? So then in order to run it, there is certain docker command you will be running it. Then that image will be in running condition, and it will convert it into the, and it will visible under the container. It will become a container only. Then in order to communicate with other docker container, because a big application, a production grade application would be having so many containers. Okay, I mean independently they will be running in their separate containers, and the communication is also required, because silos container is, they are of no use. If you are building an application and different backend, front end, or I would say AI services, they need to communicate to each other to address a business requirement, right? Then only it makes sense to enable that networking, that communication over the exposed ports. Docker networking came into the picture. It enables you to enables containers, the services which are running inside the containers, to communicate each other, right? For that, networking came into the picture. Now networking also happened. Now these components are talking to each other. Guys, what are the components I'm talking? These are the components. Okay, networking happen here. This DB expose on port number 54, 53. Now it's talking to backend, right? Backend will also be exposed on suppose 8000 port number. Now in order to communicate, they should know what port they need to send the request and expect the response, right? So networking, I'm talking in that regards. Hope you are able to connect each and everything. If you are inside my session, you should just, I mean, able to grasp each and everything. And after that session, you should feel confident. I want to ensure that kind of understanding. I want to teach at that level of uh, uh, concept so that you feel confident in very practical manner. Okay. So networking is one aspect. And then after networking, there is a concept of Docker file. So uh, generally there are some pre-built images for suppose for Python as well, or some databases as well for the Postgres, or even for the Redis as well. We generally we pull and just start leveraging inside our application or project development. But what if you are just uh, developed your application, suppose a simple Python application with hello world, and you want to dockerize it, right? You want to create a image out of it so that any of your team member can just pull it from the Docker hub, and that then start using it, and it doesn't matter which OS they are on. The underneath OS could be Windows, it could be Mac OS, it could be Linux, but it doesn't matter. That's where Docker is I mean Docker got introduced, so that we do not again fall into the challenges related to the version, I mean libraries version conflict, or platform related conflicts, right? So Docker files help you create a custom image. It has the setup instruction that this image I'm pulling, and this working directory I am making, this copy statement I'm running, this command I'm running as a application, as an image, and once that is mentioned, we can use some docker build command, we can run it, and that image can be pushed further to the Docker hub as well. Okay, so I hope the idea is clear. This Docker file will be used to create the custom image for your application. Got it? Now, as a sixth point, I will be discussing about Docker Compose. Okay, so in Docker Compose, what happens? For that, we have to go up little bit. I was discussing about this architecture. So, guys, just focus. This is very important. So, I already mentioned front end will be running on separate container, back end will be running on separate container. Let me use different color, guys. All right. Backend will be running on the different container. AI services will be running on different container. DB will be running on different container. Caching system will be running on the different container. So how we are going to manage? An nginx server will be running on different container. But the question is how we are going to manage whole system, right? That is a big challenge. For that, Dockerfile is not sufficient. Dockerfile can manage at each container level. Here we can just create the custom image, and we can post on the Docker hub so that any other team member or anyone else can use it. But in order to orchestrate each and every container underneath as a part of your application, you would require a Docker Composer file, a kind of orchestrator, so that it can coordinate each and every service underneath as a part of your full Dockerized application, I would say. Okay, so there again, there will be certain way of creating that Docker Compose file that we will be uh, learning. Okay, don't worry about that. That I will be teaching you as a part of next session. But just try to understand the significance of every terminology, every concept, so that you can able to connect the dot when in the next session I will be explaining you dockerizing something, right? Or talking about compose, networking, volume, container, image, security, blah blah things, right? Then as a seventh point, I would say what are things? Yeah, Docker Hub I have not covered. So Docker Hub. So guys, in the previous recording, in the previous session, I explained you about Git and GitHub. You remember the GitHub? GitHub is nothing but a source control platform, or source control management, right? There we are maintaining our project codes, code versioning, all those steps. Remember? Here, in case of Docker, because in GitHub we are dealing with code. In case of the Docker, we are dealing with images, because images are the starting point, a basic element of Docker that we create, right? So here we are going to manage images, okay? And for that, this is the open source platform. This is the open source platform. Okay, here the images will be pushed, stored, and as and when it's required by any developer, they will simply pull it, they run it, right? Hopefully these underlying concept you are clear as of now, right? These concepts are clear. These concepts are clear, right? Now let's go ahead and let me help you understand the installation steps so that you can set up Docker desktop locally and you can confidently step into the journey of Docker based application development. Okay, all right, let me go to the browser. So here we are. You have to just search for the Docker download. You'll get the first link. You have to just open it, right? And then you have to sign it. Guys, I have already signed in using some email ID or Gmail account. I will uh, advise you to use your Gmail account for the login. It is very simple and straightforward. I have used the same. So I'm just clicking on sign in. After signing it, it will land to the my home page. I'm currently inside the Docker. Now you can see here Docker desktop. You can go there, click on this link, and it will be able to download. You can go there and just Windows, suppose, right? And depending upon your Windows configuration, this is the uh, you are the ARM based, right? Yeah, this is x86 684. You can go to the your system configuration of your Windows machine, and you can easily identify that is ARM based, or uh, this is the, I mean, this depends upon the Intel chip or AMD chip you are using, right? So it depends. So you can simply click on these respective options and it will go and download it. Okay, see, downloading started. And then once the download is completed, you can go to the download folder and simply, because this is simple, nothing but a .exe file. After clicking it, it will help you understand the further steps. What you need to do, just follow some instructions given there, because it could also pop up for adding Docker to your path. As a path variable, you can uh, tick mark that path variable internally as a part of installation. It will help add help those uh, path environments getting added automatically underneath. I mean, you do not need to go and add those path variable from the system configuration, right? So I believe you will be getting those steps on the way, and just click it and add it. It will happen, and then next, and in no time those installation will happen. Okay, all right. Once the installation is done, you will be able to see this kind of icon, Dexter, Docker desktop. You can go there and you can click, and after opening it, this is how the interface will look like. Okay, so the images I was talking about. So see, this is the section where you can go and see the underlying images available. So initially when you will be setting up your system, I mean, for the Docker desktop, you won't be having any images since I am developing the things, and I have just created some custom images for my products and project needs. So that's where I have just implemented these images, but for you it will be vacant. But I'm just giving you walkthrough where can you go inside the Docker desktop and explore these things, image option, right? And I have explained to you about the container. So suppose this hello world is a one of the image, right? So if you look at, and there are the different images like this is skeleton AI services, and then this is the image, so many images, right? If you go there inside the container, whatever the images are running with respect to that, the container will be visible here. So you can see, so here we have Docker MySQL. This is something running currently. Underneath I am using different components, different images like MySQL DB, MySQL UI as well. uh, and that you can see as a part of image interface as well. Okay, this is my Python talking about this container. So look at, first of all, this project skeleton, it should be skeleton, only a skeleton. Go to the images. These all images are related to the project skeleton, because this is some nothing but a very big project, I would say. Come here and see, so many components will be there. So underneath there will be different containers running, right? And so the images, so that's what is trying to tell you. So there is a, if you talk about container, so container is with respect to the application. Underneath so many uh, images are running. Redis one for the caching, Postgre for the DB, AI services, and Nginx front end back end, right? And for them respective images, you can see it here. See, project skeleton hyphen nginx hyphen AI services hyphen front end back end, blah blah things, right? So these are the images. Containers will be in runnable format. So all the things are in green color. You can see these are coming as a stopping, coming as a action as a stop, because these are already up and running. Talking about the volume, I explained you this is something a persistent storage. So with respect to the applications, so suppose I'm talking about this application project skeleton, and here in this Postgre I have used volume, okay, to store the some project specific storage or customer related data storage. So for that I'm telling you, you have to go here, you have to go to where, inside the library, inside the PostgreSQL. See, and see the label are coming as a volume, because whatever the data it contains here in this directory, they are persistent in nature. Okay, that's the whole idea. Then if I talk about, I have covered yeah, networking already covered about Dockerfile. Let me tell you how it looks like, so that you have the understanding how underneath Dockerfile looks like. So if I'll talk about this Dockerfile, you can see these are the set of instruction. From there we are just pulling the image. The slim represent the light weighted images, Debian, Alpine something, and Python images I want to pull from the Docker hub. That's what I have mentioned from this command. Which version? 3.12 version. Working directory I have created. Then some requirement.txt file I have copied, which is with respect to the project development, project specific dependencies, right? Then I have run the command install these dependencies as well, so that this I mean image, this container has all the required dependencies which is required for my project development. Then there is a copy, it's copying our I mean this is the main file, actually the executable code which I'm copying from my local to the Docker container, so that from Docker container itself now I will be running, right? However, I have developed all those things in my local machine, but it should not run when I'm just running it from the Docker container. It should run inside the Docker, so that app.py file should be available inside the Docker container. And see, this is expose 8000, this is for the networking I was talking about. Then command, this is how you will be running your application on the Docker, right? So this is simple. This app.py file we are running, right, on the UV server on local host on this port. So that's how these instructions can be mentioned one by one, step by steps. And this is what a Docker file stands for. And there I was talking about Docker compose as well. See, this is how a real Docker compose file look like. It will contain so many things: nginx server, then it contains the front end, back end, AI services component that I was talking about, everything. See, environment dependencies I would have defined. Then Postgres DB, right? And then I have used volume as well for all the storage at DB level related to customer users data or anything, right? Then I have used Redis as a caching service. And in order to orchestrate each and everything, there is a term, there is a file called docker.compose hyphen compose file, YAML file that we maintain. So that I was talking about, right? So this is also completed. Talking about a Docker hub. So guys, this is the Docker hub. When once you log into the this app.docker.com, you will landed into your home page, and there option we get Docker hub. Click on explore option, and this is the place where you will be getting each and everything, all I mean all type of images will be are hosted here already. And they are categorized into the different segment. It's related to some machine learning, deep learning, AI based programming language. You can come here and see the categories, right? And suppose in language and framework category, I just clicked it here. See, the Python is there. And even let it be, if I want to use Spark, if you are a data engineer, you do not want to waste your time setting up the environment, right? You want an environment where Spark related dependencies are already installed and your environment is up and running in that. So in that scenario, what you can do is just search for the Spark. See, there are 1 million plus download of these images. So it is the I mean your production ready environment with all the dependencies related to Spark is installed. You can just click it here in order to use it, and you will land it this page. You can go down and you can use it. Okay, this is the way it is explained, that after logging it, after setting up the container, you can use it. There will be some command. See, you can use this command to pull this image which is preloaded with Spark and related dependencies. Ready, I mean, it's already cooked thing, already prepared environment. You just need to just pull that image, Spark image, in your local and start building your work. Similarly, if you want to work on a RAG application, you would require the LangChain as well, right? See, LangChain, how many downloads? 100K plus. You can go there, you can just pull the image. Now now the LangChain is already set up. How easy it is, right? And it will not break further due to the those leverage dependencies, due to conflict in the version, OS, what all things, right? So yeah guys, this will I will explain the part of practical implementation. I believe I have covered all the conceptual aspects of Docker and important components terminology, so that you are at a phase, at a stage where you can confidently enter into the journey of Docker, and you can confidently build your production grade system using Docker. Okay, so everything is neat and neat and clear in your mind, right? No doubt, no confusion. So uh, I hope guys you have learned something today, and with that I'm signing off for today. But remember, keep learning, keep growing, and keep building together. Bye bye.